Advanced Math, Lesson 9, Congruent Figures and Proof Outlines. So this is kind of a strange lesson to do a video for, but we'll attempt it anyway. The main thing that we're going over here is what makes triangles congruent. And you should have already memorized these from geometry, but if you're a little behind or if you need a little refresher, they're all in this lesson on your book, mostly on page 68 and 69. But the ones that we're going to be using are the side postulate, the side, the angle side angle. Let's see here, and the hypotenuse leg. I believe those are the main ones that this book uses. I think there's one or two other ones that are not as common, and I think these ones will suffice. Or you don't know, I'm sorry, I'm thinking of similarity postulates. These are all the congruency postulates. So side, if you can prove that the three sides of any two triangles are all the exact same length, then you know that those triangles are congruent. Side, angle, side, if they're, if you have a side, an angle and a side that's the same in two triangles, they're congruent. Angle, side, angle, so angle, line, angle, line, angle, that will prove that it is congruent as well. And hypotenuse leg. So for right triangles, if you have the same hypotenuse and the same leg as another right triangle, then those triangles are congruent. Now let's go on to proof outlines. So proof outlines aren't the same as doing a full-blown proof. They're much, much easier. For example, 9.2, they give us this triangle. They tell us that angle E and H are equal to each other, and that line EF and GH are also equal to each other, and we need to outline a proof that would prove that line DF is equal to line DG. Now I've reconstructed this over here, and I put tick marks showing what they told us, and they told us that this angle and these two sides were equal to each other. Now to outline a proof, all you simply have to do is just write the steps that would lead to you being able to prove that those lines equal without putting all this stuff in between. So if I look at these two triangles, I've already got a side and an angle, a side and an angle. What would help me prove them congruent would be another angle or another side. Now how can I get that? If I look at this, I can say, hey, this triangle, this big triangle, EDH, is going to be isosceles because of the two equal base angles. So I'll know that these two sides will be equal. I don't have to write that though. I just know that I can prove that these two sides are equal, so I can prove that these triangles will be equal by side, angle, side. So for my first line, I'm going to put triangle EFG equal and congruent to triangle, triangle GHD, and that's going to be through side, angle, side. Now the second line is, once I prove that these two triangles are equal, then I can prove these lines are equal. So then I could say DF equal and congruent to line GH by congruent parts of congruent triangles are congruent. CPCTC. So just geometric stuff that you should still remember. If you don't remember CPCTC, that's congruent parts of congruent triangles are congruent. That's something you're going to be using a lot. And this is your answer right here, just these two lines. They just want to know that logically you understand what two triangles need to be proved congruent, and then what methodology, and whether or not those will help you prove the parts that you're looking for that are equal, whether it be a line or an angle, or whether it just be triangles. So proof outlines are very, very simple. You don't have to go through all the nitty-gritty, all the extra lines of saying that EDH is an isosceles triangle, and then because and then you can say DE is equal to DH because definition of an isosceles triangle, and then you'd be able to go onto this line and that line. Outlining proofs is much simpler. You're just going straight to figuring out which triangles you can prove are congruent, and then what that says for your final answer. All right, and that's really it for this lesson. So again, if you have any questions, feel free to ask me on Moodle.